Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. So this is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years to excel in mathematics. And today I teach mathematics and today I'll continue limits. So we have already done one session on standard limits and this is continuation of that. So remaining standard limits we'll cover today. Okay, and then we'll start indeterminate forms also. Other indeterminate forms like 0 by 0. So mostly standard forms are of 0 by 0 form. Okay, and then other indeterminate forms we'll do later. But before the beginning, let me tell you about the Unacademy subscription. So, as you know, Unacademy is India's largest online learning platform. And once you get the subscription, you can get subscription for Plus and as well as Iconic. All right. So let me tell you about the Plus subscription first of all. So as you know, if you get the Plus subscription, then you get daily access to daily live classes of all the educators who are teaching for IIT-JEE, all physics, chemistry, and maths. So you can follow any educator of your choice. So India's top educators are teaching on the platform. You can follow them. You can follow anyone's course. Okay, that is your choice. So you have complete freedom. It is unlimited access you are getting after getting the Plus subscription. All right, and you can also watch their sessions offline if you miss something. You can download the recorded session and watch them offline. All right. These live sessions are very interactive. Very interactive means you can participate in poll, you can ask your doubts, you can send images. All right. So there are many features. You can attend special classes without even getting the subscription. All right. So all special classes are completely free. Every day, many educators are taking special classes on the platform. So you can attend these special classes. Just download the application on Academy's learning app and make your account and start learning. All right. So, excuse me. So you can start your preparation and on various topics every day. There are many special classes going on, so you can attend unlimited special classes for free. Live test and quizzes also you get unlimited access of live test and quizzes, all India test series once you get the subscription. And the courses which I was talking about are well structured. That means everything is pre-planned. You can see the schedule of all the upcoming lectures in very advance. These are the subscription charges. For 1 year it is 38,500 and for 2 years it is 56,000. And you get 10% discount and these will be the amounts then. Use my code JEET1 to get instant 10% discount. Now this is not about Iconic subscription. In Iconic subscription you get all the benefits of Plus, which I was just talking about. All right, so you get all the benefits of Plus, and apart from that, you will get a personal coach or an expert, you can say, who will guide you throughout your preparation for all the top exams like IIT-JEE Advanced, IIT-JEE Main, JEE Main, and BITS and all. All right, so for all top exams, you'll get a personal coach. Personal coach means an expert who will guide you for all throughout your subscription. All right. All test analysis will be done in a personalized manner. Feedback will be given to improve your time management and exam approach. Your study planner will be customized. All right. Bi-weekly reviews will be given to highlight your progress. So these are the extra features you get in Iconic subscription. And this is 1 year's charge, and after 10% discount, this it will be 50,400. So use this code JEET1 to get this discount. And for 2 years, it is just 86,000. And use my code, and you'll have to pay 77,400. All right. So use this code JEET1 and pay just 77,400. All right. So you can download this Unacademy's learning app from Play Store, and after downloading, you can start learning. Start special classes. You can get quizzes also. All right. So just start your preparation. Now today, as I told you, will continue standard limits. So we have already done 3 standard limits. Let me do the quick revision. Sin x upon x when x approaches to 0, limit this limit was 1, and precisely it was approaching to 1 from left hand side, all right, slightly less than 1. So if you take greatest integer, then it becomes 0. And then we did sine inverse of x upon x, right? It was just opposite to sine x. That means limit of this was 1, but it was approaching to 1 from right hand side. It was slightly greater than 1. So if we take the greatest integer of this, it will become 1. Now next we did was tan x. So that was tan x upon x when x is approaching to 0. All right, limit x is approaching to 0, and that is going to be 1, and that was also 1 plus. All right, so these three limits we discussed yesterday in my previous session. Now I'll continue next standard limit. So fourth standard limit is tan inverse of x upon x, and as you know, the graphs of tan and tan inverse are basically mirror image of each other about y is equal to x line. So let me explain this through graph first of all. We just need to compare the graphs around origin, okay, in a small interval around origin. So let's make the graph. This is the graph of tan. If you remember, it was above y is equal to x line, all right, and they were y is equal to x line was tangent to this curve at origin. This was the graph of tan. After this, now we plotted the graph of y is equal to x line. So y is equal to x line is tangential like this, and then you can plot tan inverse. All right, so you know how to plot. Just take the image of y is equal to tan x about this curve. So this is going to be like this is your tan inverse. All right, so you can see tan was above y is equal to x line, and tan inverse will be below this line, positive side. If you look at the graph on the positive side, all right, positive side of x-axis. So this is tan inverse. So clearly you can see that tan inverse x upon x, tan inverse x is less than x when x is positive, and tan inverse x is greater than x when x is negative, right? So if you find the ratio, this tan inverse of x upon x, this ratio is actually always less than 1, right? And even here also, if you divide by x, it is going to be tan inverse x upon x, and inequality will be reversed. Why? Because it is less than 0. So you are dividing by a negative number, so inequality will be reversed. So you can see whether x approaches to 0 from right hand side or left hand side, tan inverse x upon x will always be less than 1. So actually this limit approaches to 1, but now we know that it approaches to 1 from left side. That means it is slightly smaller than 1, all right? That is the main point. You can also explain it in another way, like in tan inverse x upon x, limit x approaches to 0. In this, just put x is equal to tan theta, this substitution, put x is equal to tan theta. As x approaches to 0, tan theta approaches to 0, and theta approaches to 0. Theta also approaches to 0. So your question will become tan inverse of tan theta divided by tan theta, right? And you know tan inverse of tan theta, tan inverse of tan theta is actually theta when theta belongs to minus pi by 2 to pi by 2. So yes, theta is very small, it is close to 0. So obviously it will be theta upon tan theta. All right, theta upon tan theta when theta approaches to 0. So theta upon tan theta is basically 1 minus. You can see it is 1 minus. Why? Because tan theta upon theta was 1 plus, so reciprocal of that will be 1 minus. Okay, so actually limit is 1, but now we know that it is slightly less than 1. Hi Rakesh. Okay, so if I ask you this question, what is the answer of this? Tan inverse of x upon x, x approaching to 0. Can you answer this, Rakesh? How are you? Can Think about it. What would be the answer of this? That's why we are understanding it, whether it is 1 plus or 1 minus. All right. Hi, Bobji. So you're getting 0. Yeah. Yes, it is 0 because this will be 1 minus. All right, and 1 minus, and then you are taking the greatest integer of 1 minus, and that will be the limit. Okay, so 1 minus is basically 0. So yes, answer is 0. Very true. Good. So this was again standard limit. So now I will give you a question based on all the 4 limits which we have done. Okay, and then you can answer this. See, it is the sine inverse of 2x divided by tan, wait a minute, divided by tan inverse of x, and then it is tan of 4x divided by sine of 2x, and greatest integer of this, and x approaches to 0, right? Try to find this. Okay? Think about it. What could be the answer? It's a very, very good question. See what is the answer of this? Yeah, let me explain. So, sine inverse of 2x. Let's divide by 2x. Okay, and will multiply by 2x also. Multiply by 2x. Similarly, make this also standard, tan of 4x upon 4x. This approaches to 1, right? Approaches to 1. But in this case, we need to figure out whether it approaches to 1 from right side or left side. That is an important point. And then there is going to be tan inverse of x upon x, multiply and divide. And then there is going to be sine of 2x upon 2x. Alright. This is the expression now. Now we will put like 1 plus delta, 1 minus delta. If it is 1 plus, then we will put 1 plus delta. If it is 1 minus, we will put 1 minus delta. Alright. Also delta 1, delta 2 might be different. Okay. So x and x will get cancelled, and x and x will get cancelled. So numbers remaining, and 2 will also get cancelled. So the number, numerical value remaining is 4. Sine inverse 2x upon 2x, we have just, actually we did yesterday. Sine of 2x, sine inverse of 2x upon 2x is 1 plus. Basically, sine inverse of x upon x, x approaches to 0 is 1 plus. So sine inverse of 2x upon 2x will also be 1 plus because 2x is approaching to 0. Alright. Now that will be tan of 4x upon 4x. So tan of 4x upon 4x will also be 1 plus. Alright. And divided by tan inverse x upon x. Tan inverse x upon x is 1. Tan inverse x upon x is 1 minus. We did put it, right? And sine 2x, sine theta upon theta is also 1 minus, right? Okay. So now you can see 1 plus into 1 plus number slightly more than 1 into another number which is also more than 1 will give you a number which is more than 1, alright? So this is nothing but 4 into 1 plus upon 1 minus. 1 minus into 1 minus, like 0.9 into 0.9 will be actually less than 1 only, right? So number which is less than 1 multiplied to another number which is again less than 1 will be actually less than 1, alright? So 1 plus, now it is 1 plus upon 1 minus. So numerator is slightly more than 1 and denominator is slightly less than 1. So this ratio will be again 1 plus. So it is going to be now 4 into 1 plus. 4 into 1 plus. 1 plus means 1 plus delta. And that is like 4 plus, right? 4 plus, or you can write 4 plus delta. So greatest integer of 4 is 4. So that is your answer. I hope you understood. So answer will be 4. It could be 3 also if you reverse the whole expression. I mean, if you take the greatest integer of this, it is tan inverse of 2x, and yeah, you have to change the angles or arguments. Tan inverse of 2x sine of 4x divided by, if it is sine inverse of x and tan of 2x, then what is the answer of this? Now this is going to be greatest integer of 4 minus, alright? Because in denominator we had 1 plus, in numerator we had 1 minus. So overall, as you see, numbers are same, so it is going to be 4 only. So 4 minus, and then greatest integer of number, which is slightly less than 4, is 3. Alright, so this answer is going to be 3. So I hope you got it. Now let's move to another one. Next is standard form. So fifth standard form is limit x approaches to 0 e raised to x minus 1 upon x. Now this one is going to be very, very important. Important in the sense that this is different from the previous 4. It is different from previous 4. I'll tell you how. First of all, we need to know the graph of e raised to x minus 1. So I plot some graphs here and we practice. Okay, I'll plot the graph here. Next slide. So this is e raised to x. This is e raised to x. And if you want e raised to x minus 1, then this graph will shift by 1 unit in downwards direction in along y-axis. So this is the graph of e raised to x minus 1. Okay, now it will pass through over here. And if you check the slope of this curve, y is equal to e raised to x. If you check y dash, that is going to be e raised to x, and y dash at x is equal to 0 is going to be 1. So here slope is 1. That means if you plot y is equal to x line, then it is going to touch this curve like this. Alright, and yeah, it will be below. You can see that graph is concave up. So you don't need to think a lot about it, because it is concave up, so it is certainly going to be more than, above y is equal to x line. Or you can also see that y is equal to x will increase its value as you increase the value of x. As you go positive side of x axis. So e raised to x will become more than, that means rate of increase of e raised to x will be more than the rate of increase of y is equal to x line. So it will go up. So that way also you can out there. Now let's plot the graph here. So if I plot the graph here, it is going to be okay. So e raised to x minus 1 was like this. Right. And you got y is equal to x line. So y is equal to x line will touch this curve at origin. At origin like this. Right. And yeah, this difference will keep increasing e raised to x exponential function. Okay. Audio is not clear. Oh yeah. Thank you. Let me check. Wait a minute. Which audio sorry, what is this play? Oh dear, what happens to audio? It is default only. Hello. Yeah. Hello, hello. Now I think it is. All right. Let me check. Yeah, yeah. In the beginning it was good. Just now it is started. How's it now? How's this now? Yeah, no, I think it's fine. Are you getting the voice clearly now? All right, so let's continue. So you can see e raised to x minus 1 is always e raised to x minus 1 is always greater than x for all x, all right? Or yeah, they are equal for all x belonging to real numbers minus 0. For 0, they are equal, right? For 0, they are equal. So now you can see one important point here arises, and it is different from all the standard four standard limits which we have discussed earlier, that if you divide by x, then this is going to be more than 1 when x is positive, but when x is negative and you're dividing by x, then inequality will reverse, right? So e raised to x minus 1 divided by x will be less than 1. So right hand side, you can graphically you can see that magnitude of e raised to x minus 1 is greater than the magnitude of x. So that's why this ratio is coming out to be, this limit is actually 1, right? This limit is 1 because both have same value at x is equal to 0 and their slopes are same. So they will start increasing at the same rate, and their values for x more than or less than 0, slightly ahead of 0 or slightly before 0, they will be almost equal. So ratio will be 1 only. The ratio will approach to 1, but from which side it is approaching to 1, that is our question. So it's if x approaches to 0 from right hand side, that is called right hand limit. So it is going to be e raised to x minus 1 upon x. This limit is going to be 1 plus 1 plus. All right. That means it is approaching to 1 from right hand side. That is the only thing. Okay. And left hand side, if x approaches to 0 from left hand side, then e raised to x minus 1 upon x, this will approach to 1 from left hand side. All right. So that is the main thing. Now, from both sides it is approaching to 1 only. That's why limit is 1. Okay, so limit is 1. Limit does exist. Limit of this function does exist, and it is 1. Okay, it doesn't matter from which side it is approaching to 1. So limit of e raised to x minus 1 upon x is 1. But why are we studying this? Because if you have this question, greatest integer of e raised to x minus 1 upon x, limit x approaching to 0. Now this is a very, very good question. Okay, now what will be the answer? Try to answer this. Vamsi, Siddharth, Rakesh, anyone, try to answer this. Tell me what will be the limit, right hand or left hand? This is greatest integer function. This is greatest integer function. Guys, getting any answer? Yeah, true, Vamsi. Yes, it does not exist. So what are the limits you're getting? Right hand limit and left hand limit. So if you calculate right hand limit and left hand limit separately, yes, you'll have to because you have greatest India function. So in previous four standard limits, left and right limits was same. But in this case, left limit, right hand limit, when x approaching to 0 plus, this e raised to x minus 1 upon x approaches to 1 from one right hand side. That means it is 1 plus. And what is the greatest India of 1 plus? It is going to be 1 only. But from left hand side, when x approaches to 0, from left hand side, this ratio e raised to x minus 1 upon x approaches to 1 from left hand side, that means it is slightly less than 1. Okay, so the greatest integer of that is going to be 0. So you can see right hand limit is 1 and left hand limit is 0. So they are unequal and hence limit does not exist. So I hope you have got this point. This was very important point. All right, I'll give you two more questions, so try to solve these two questions. Now I can frame a lot of good questions, and most of the students will make mistake in this. So e raised to, I'll start with simple question. E raised to x square minus 1 divided by x square. All right. And you need to find the limit of this. And square bracket means greatest integer. All right. This is greatest integer function in all the questions. In all the questions. Limit x is approaching to 0. Now my second question is limit x approaching to 0 e raised to minus x square minus 1 divided by, all right, hmm. Hmm. Limit of this. And my third question is this: limit of x approaching to 0, sine of wait a minute. These are few very good questions. Try them. Try them and I'll discuss with you. Try all three. How are you, Siddharth? What's going on? All right, let me discuss the first one. So what is the answer of first? See, it's very simple. If you take x square is equal to t, you can take x square is equal to t. Then when x approaches to 0, then x square will always be positive. That means x square will also approach to 0, but it will be a it is 1. Then t will also approach to 0, but from positive side only, right? And then your question will become e raised to t minus 1 upon t, where t approaches to 0, where t approaches to 0 from positive side. And you know that is nothing but 1 plus. And greatest integer of 1 plus is nothing but 1. Okay, that was the simple question. Now in this you should take minus x square is equal to t, all right? So when x approaches to 0, minus x square will also approach to 0, right? But minus x square will approach to 0 from left hand side, okay? So when x approaches to 0, x square will approach to 0 and t will also approach to 0, but from left hand side, okay? It will be negative. So now your question will become, this question will change to greatest integer of 1 minus e raised to t minus x square is t. So x square will be minus t, all right? And t approaching to 0 minus. Now remember that we are checking the left hand limit of this function, okay? Left hand around origin, left hand side of origin. So t, when t approaches to 0 minus, and you know left side of origin e raised to x minus 1 upon x is nothing but 1 minus. So this limit is going to be 0. So second answer is 0. First was 1. Now what is the answer of the third one? Try the third one. All right. Now let me do the third one also. So in this case, what you need to do is put minus sine square x is equal to t. So you can see whatever is there as an exponent of e, I'm putting that is equal to t. So minus sine square x is equal to t in this case. So when x approaches to 0, sine square x will also approach to 0 and minus sine x square will also approach to 0, but from left hand side because of this minus, all right? So t will approach to 0 from left hand side, okay? So now this point has become important, whether t is approaching to 0 from right side or left side or from both. Okay, if it would have been x or sine x, then for x 0 plus, sine x will be 0 plus, for x 0 minus, sine x will be 0 minus, all right? So t will approach from both end side. But because it is sine square, so sine square is positive and minus sine square is always negative, so t will be negative only. So it will approach to 0 from left side only. So now your question will become, this will become 1 minus e raised to, okay, before doing this, I need it to change something. Okay, what is that change? I'll tell you. You could divide and multiply by sine square. So it will be sine square x upon x square. Club this x square with sine square and write this as e raised to minus sine square x minus 1. I've taken minus common. That minus I'll take to denominator and write like this, okay? So basically I've got two questions, okay? For this particular I'm doing the substitution, but second one I'm not doing, okay? For this I'm not doing, just to check, okay? So do it separately. I just want to check whether it is minus sine square x minus 1 upon minus sine square x, whether it is 1 plus or 1 minus. I just want to check that, all right? So using this substitution separately we can check, okay? And then we'll use it in the given question. So you can see it is going to be e raised to t minus 1 upon t, and t approaches to 0 minus. And when t approaches to 0 minus, so this approaches to 1 minus, right? So it is 1 minus. I think you have got it. And sine x upon x we already know is 1 minus. So it is 1 minus sine square upon x square is 1 minus into this is also 1 minus. So 1 minus into 1 minus is 1 minus only. 1 minus means slightly less than 1. And greatest integer of that is going to be 0. That is the answer. So answer of this question is 0. I hope it is clear. This was a very, very good question. Okay. So I'll tell you the last standard form. You try to understand this. See if you have any problem. Let me know. All right. Let's do the next form. What is the inverse function of this? Inverse of e raised to x minus 1 is ln of 1 plus x. Why I'm telling you this? Because as we did sine x, sine inverse, tan x, tan inverse, similarly e raised to x minus 1 upon x and inverse of it. So inverse, as we are taking the inverse of, so you can see the graph of y is equal to ln 1 plus x will be the image of graph of this function. This was e raised to x minus 1 and this will be the graph of ln 1 plus x. Okay, so this is ln 1 plus x. This is e raised to x minus 1 and y is equal to x line will pass through origin and it will be in between these two functions. Actually, these two graphs are mirror image of each other about origin. This is the first graph and this is the second one. All right. This is ln of 1 plus x. So I hope you're getting it. Now we are going to do standard form based on this. So what is the last 6th standard form? That is ln of 1 plus x upon x. All right. When x approaching to 0, limit of this is basically 1, right? But now we need to figure out whether it is 1 plus or 1 minus. All right. So now we can do this easily. We have already done 5 standard forms using graphs. So it will be opposite to e raised to x minus 1, right? Opposite. That means right hand limit of e raised to x minus 1 was 1 plus. So right hand limit of this will be 1 minus. And left hand limit of that was 1 minus. So left hand limit of this will be 1 plus. It's opposite to that, all right? Opposite to that. And using graphs also you can see y is equal to x line is greater than ln of 1 plus x is smaller than x when x is positive and ln of 1 plus x is more than x when x is negative, right? So if you divide, then ln of 1 plus x upon x will be smaller than 1 when x is positive and ln of 1 plus x, similarly here also if you divide, inequality will be reversed because x is negative. So I'm sorry, I've written it wrong. Here ln of 1 plus x is still less than, all right? It is always less than. So it's still less than. And after dividing it will be more than, okay? So from this we will get the right hand limit, for left hand limit, because this is for x less than 0. And from this we'll get the right hand limit, all right? So if I write the right hand limit precisely from which side it approaches to 1, then actually it approaches to 1. It approaches to 1 from left hand side. Okay, that means that it's slightly smaller than 1. And if you check the left hand limit, then ln of 1 plus x upon x, limit x approaching to 0, this is going to be 1 plus. All right, this limit is going to be 1 plus. Are you getting this? So these are the limits. That means if I ask you this question, ln of 1 plus x upon x, greatest integer of this, x approaching to 0, so now you can answer this, right, easily. What will be the answer? Think about it. So its right hand limit is going to be greatest integer of 1 minus, and greatest integer of 1 minus is nothing but 0. And its left hand limit is going to be 1 plus, and 1 plus is going to be 1. So limit still does not exist. Limit does not exist. I'll give you some questions. Try this. Try to figure out the answer of this. Very good question. What's up, check? All right, so let's do it. Like in the previous question, you can put x square is equal to t. All right, so when x approaches to 0, t will approach to 0 plus, right? And this question will become ln of 1 plus 2t upon t. In fact, you can take 2t, 2x square is equal to t. Then also it will be 0 plus. And then you can write, it's better to take 2x square is equal to t. So it will be ln of 1 plus t divided by, you need to multiply and divide by t, so it is going to be 2x square, so 2x square will be t. Now t is approaching to 0 plus. So 0 plus, 0 plus it was 1 plus, ln of 1 plus x upon x, right hand side was 1 plus. So it will be 2 into 1 plus and it will be 2 only. All right, one more. This is going to be very, very good question. Try this one. Very smart question. All right, so let's see. If you see the limit of this function, then it is going to be, now you need to take sine square x is equal to t first of all, right? And t will approach to 0 plus as x approaches to 0, because sine square is a positive number and it approaches to 0. So it will be 0 plus. Then it is going to be, okay, it's better to take minus sine square actually, because you can see minus sign is there. So take minus sine x square, and now it is not going to be 0 plus, it is going to be 0 minus. All right. So it will be ln of 1 plus t divided by minus t will appear, right? All right, let it be. And t is approaching to 0 minus. Now, you know, for 0 minus, ln of minus 1, right, like this. Ln of 1 plus t, ln of 1 plus t divided by t. Okay, what was this when t was approaching to 0 minus? It was 1 plus. I think I did a mistake here. I'm sorry. In the previous question, it was a mistake. What was the mistake in previous question? When x approaches to 0 plus, ln of 1 plus x upon x was 1 minus, not 1 plus, all right? So I'll change it here quickly. I just did this mistake. So it was 1 minus, and it will be 2 minus, and 2 minus greatest in here is 1. Now when x approaches to 0, t approaches to 0 from left hand side, then ln of 1 plus t upon t will be 1 plus, all right? So now this is going to be minus 1, because minus 1 is a product. So write 1 plus delta, okay? It's better to write 1 plus delta. Delta approaching to 0. Now it is going to be minus 1 minus delta, and delta is approaching to 0. So you can see this number is between minus 1 and minus 2. So greatest integer of that is going to be minus 2, all right? This one. I hope you have got it. Okay, so these were standard limits. Now I'll continue indeterminate forms in next session also. Okay, till then, take care and subscribe the channel and like